going to be attempting quest 10 of Everybody Codes. Got my examples ready to go, template ready to go, inputs, outputs while I'll be running. I wasn't able to attempt it, I believe, the Friday it came out, but that's why you love them local leaderboards and all that. So here we go. Here are our notes. Something, something, something. Runic word, blah, blah, blah. Okay, we love runes. We love the lore. Okay. Each empty space is a symbol. There's always one matching symbol. Once they're all filled, okay, for the first field marked with a dot, the corresponding row contains BVPT and the column contains PRFG. The only that is in both is dot. Okay, so I find everything that is in the same row in the same column. What about things that I populated? Do those count as the same row and same column, or is it the outsides of this? I don't know. We're about to find out. Okay. So const world equals notes dot split on the new line dot map line. Gotta convert these to arrays because we're gonna be manipulating them. Okay, and basically you just need to find the dots and then traverse all rows, traverse all columns, right? The corresponding contains BVPT. BVPT. Okay. PRFG double is P. I want to see something being considered twice. Okay, I'm not seeing a color. I want to see if there's a green in here, but it's not. Okay, I'm just going to go with it. For let r equals 0, r less than world.length, r plus plus. For, oh, not a const, not yet. For let c equals 0, c less than current world, row.length. We can handle these rectangles. C++. Okay, then we're going to say if world rc not equal a dot, continue. Not confirm, continue. There we go. Otherwise, we are looking to get all the characters in the row and all the characters in the column. The only symbol up here is both row and column is P. Const row cars. Sure, let's do that. For let r2 equals 0, r2 less than world length 2 plus plus. So that'll be if world r2 c. I think I'm just gonna add it. Wait, there are these asterisks and then there are these characters. Let's just add it. We'll filter it later. Row cars plus equal. Boom. Assign it to constant variable. Let's fix that. Let. We'll do the same thing for call cars C2, but instead of this, R C2, and it's world R length. There we go. Row cars equals row cars dot replace any dots globally with nothing. Replace any asterisks globally with nothing. I think do the same for call cars. Hopefully that's all of them. And now we need to find the character that is in both. So for const c of c C car of row cars if call cars includes car found. Then we say found equals car, and then we'll break. I think that will be valid because appears the rule that there's going to be one in both, so I don't matter which one I search. Now I can say world rc equals the one I found, right? That's the idea. And then we put them all in and we read the ones that we added. So since I'm doing it row and column, let new cars equals this. So new cars plus equal found. Then theoretically I can just return new characters. Okay, it's working for that one. Expected, I need my input. There, these characters. So we're risking it now. Boom, okay. Each symbol is a base paddle. Okay, so great. So we can turn that. Okay, this is great. This is great. So yeah, function solve quest 2 notes string const word equals solve quest notes. Now we do power calculation. So it's index times thing. So let t2 total equals 0 for let I equals 0, I less than word dot length, I plus plus. So each symbol is a base power. Const BP equals word. Well, let's do const C equals word C. C. I need to do the math. I need solve quest 2 in here. I need it on my example. I don't have it on my example. Previous part. Oh, what the heck is that fancy copiness going on? Oh, geez, that's real fancy. Okay, what's the output here? 1851. Let's put that in there, not there, over there. Focus on this one. Can I access C before initialization? Yeah, I'm getting there. Alright, so I need return C. Show me the character. Okay, we're looking at P, and then C.car code at 0. So I know it's a car code at 0. Largest minus smallest, so it will be that one minus that one. Code -17. Dang, I went the wrong way. Don't know how I did that. Wait, we have capitals in here. I need capital A, not lowercase a. 15. Okay. Let's imagine C equals capital A. Code is 0. It is supposed to be 1. So let's do a +1 on this equation. There we go. We found base power. And let me back in that. Boom. Base power is this. Drop all this random stuff. What do we need to do next? Base power multiplied by position and word. And it is 1 index. So total plus equal I plus 1 times BP. Make sure that math happens first. Return total. Yes. Okay. Unfocus. Expected 0. Oh, gotta put in the input. That's right. Boom, boom. Oh. I wasn't anticipating this. This doesn't look like this is not the input I was expecting. I'm also expecting to see output here. Could we get output, please? A stack of training samples, all the runic words, the sum of their powers. Okay, so I'm doing splitting and then I'm doing space splitting. I was not prepared for this. My sample did not prepare me for this. Solve quest 25, I guess. It's 2.5, but I ain't got that in there. So I need to split based on double new lines. And for each of those, I need to split, find the indexes of the thing, and do string thingy bobbing. Okay, let me just copy a chunk of this. Cost stack to parse stack things equals notes string, and let me write test parser const raw equal backticks. I need to read this with my eyes. Let's keep it going, Albie. I'm going to make this into a 2x2. So, nope, wrong way. You know what? I'm not gonna make it into a 2x2. I lied. Const res equals parse stack thing raw. I think we just want them all, right? Expect res dot length to have length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 30. We're looking for a 30. Okay. They're all square, thank goodness. Let's get this arrow on here. Const row equals notes dot split on the double new line. Length. This is the part where you do the thing. Hello? Hello? Oh, do I need to focus on you? Okay, fine. We got 2 rows. We just need to, for every line, so for every line, if I split on the new line, my brain is just not liking this one. For const L, row of rows dots return const L equals row dot split on the blank line. I'm expecting to see, yeah, all the different pieces of it. So now I need to iterate through each of these and put them. I'm not expecting to see this. Oh, for a row of rows. Yeah, for group of rows. Is this what I wanted? I'm seeing a visual pattern, but I don't think that's what I want. So we have the beginnings. My brain hates this. I feel like I should be using regex here or something. They have fixed size. What if I just go for that? So I just need to count and then I can start mathing my way through it. So rows of stacks dot length. So yeah, let's just look at that. There are 2 rows. Okay, now let's do cost columns of stacks equals notes dot split by 1 new line 0 dot split by a space dot length, and then if we have that right, 15. Yeah, that is 2 by 15. Okay, so I just need to say const inputs equals empty array of strings for let r equal 0, r less than rows of stacks, r plus plus, for let c equal 0, c less than calls of stacks, c plus plus, and these don't need to be rc, these need to be sr and sc for the stack row and stack column, because I'll need another one for calculating the individuals. So const input width equals 1, 2, 3, 4, 5, 6, 7, 8. Const input height equals 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what we need to do is calculate our starting position, which is this plus this times however many we're off. That misspelling is hurting me. There we go. Const let r equals sr times 8 let C equals SC times 8. But I need to do +1 for every one I'm over. So if I'm 2, that's +2. So this is just SR plus SR. No, SR plus 8. And then I do the multiplication plus SR. Let's see if that works. Now I just need to R. So 0, 0, 8, 16. So 0, 0, 0, 8. So let's column 0, 1, 2, 3, 4, 5, 6, 7, 8. Nope, it's not enough. It would help if I was doing that one. 9. There we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Let's get to the next row. Oh, I literally can't see them line up. But it's going to the next 9. So that makes sense because I have 2 of them. Okay, now I can build the string. Let lines equal an empty array. Or let, well, we have them set already. For let r less than input width, input height, r plus plus. Need to make sure those are the right indexes. I need a parenthesis, of course. Yep, those are correct. Everything else is on fire. It's all good. Exact same thing, but dealing with C's and SC. Input width. There we go. Gotta bring the lines up. Let's get formatting a little better. And then we have let line equals empty string. So this will be notes RC line plus equal. And then lines dot push line. Once we have all the lines, it'll be inputs dot push new line join lines. That's Python. I'm not writing Python. Much apologies. Dot join the new line. Let me check. It's still going. And then I return inputs, which will be 30, and it is 30. So I can just trust that this works and see if it works. So let's drop that log, drop that there. So solve quest 25 is, where's 25? There it is, 25. Const worlds equals parse stack thing notes. Then for const world of worlds, do everything in here minus the input. That one lives outside. Let's call it a raw world. Let's call it something. Okay, we're doing that. Something could have been wrong with what we've got going on here. Have I used 25? It's saying it's red like I have. So either it's working and it's telling me there's something wrong, or it's not working. I don't have an example to run this on. Focus and focus. Stop wallaby. Get a normal run on this. I'm getting a 0. Yeah, it ain't working, chief. We gotta debug into this, make sure everything is doing what we want it to. Let's start with the worlds. Maybe they're broken. Worlds, 105 worlds. Yeah, that ain't right. That ain't right. That ain't right. It's not supposed to be a bajillion undefined bits. Did I not have a trim in there, or? Boy, that thing went horribly wrong. Let me check for a trim. I shouldn't even need a trim. Gonna chuck it. Yeah, so I have the input. Let's go into this function. It's not handling our special case. Okay, let's see what we got. 7 rows. It's at 15 columns. That feels right. The widths are 8. The widths are 8, yes. Let me look at it for my eyeballs. Okay, I can see it. Right. And then it gets cut off. Sure. Something is wrong here. This is just great. Yeah, we're starting in 0, 0, right? And we're going to build that line up. A bunch of undefines. What's going on? Why are we not accessing things correctly? We got a star, and we got a dozen undefines. Let me back in. So, we have R, we have C. We're accessing notes. Notes. R. Oh, it's not in split. Don't know how this is working before. Not gonna question it. Cast raw lines equals notes dot split. New line. Not gonna worry how this didn't get caught in my test, but it's fine. It's because I wrote a test based on length. That's why. We get lucky. That's a number. I'll take it. Okay, I'm unloading the warning. That's making me think like I didn't do that. Making me paranoid now, little buddy. Okay, stop that. I am, okay. It just ain't doing its thing. So, it's not correct. Let me look at the worlds that are parsed out then. Next line, what do we got? We got 105. It's not like the freaking prototype. And then this guy doesn't... It's not doing the thing. Let me back in. Would it be easier, or would there be an easier way for me to just do this myself? I target this. I'll have a lot of cursors. Oop, not there. Let me try and do this. So I'm here. How do I do... Nope. Nope. Rules weak, and it's gone. Okay, I tried to be cheeky there. If I just target every space, that'll get me all the way up there, and then I think those are new lines. Yes. Okay, I can do this. Write code to parse? Nah, use shortcuts to parse. So now those are each individual lines in this string. It's gonna be hard to do unless... Nope, that broke it. I should need to get them... Nope, okay, this is hard than just writing the physical code, I think. Okay, let's figure out why this code ain't coding. Let me in, and let me in. Basically, the deep bows. So the first one looks like it generated correctly. You see the lines. The lines. That's what I mean. And you see the end states technically. Star, star, JFB. Yeah, okay, I'm happy with that. JFBN, we're good. WK, good. NR, we should see LX, we should see TV, we should see BH, we should see DH, we should see SK. We see them all, we push them, we go into the next. Okay, the next one I feel like is where we get the concern. Let's jump in there. Okay, yeah, we finish up. Good, whoopie woo. Nope. No, this is it. It's not supposed to end there, it's supposed to go further. SC. So we start and then we just go 8 times. Let end, I need to find an end, which is this plus 8. This plus, yeah, sure, this plus. That might be it. I need to see. Let's run it once more. You know what? I don't care about the other breakpoints. Just show me the magic. 105 worlds. Do they look good? They don't look good. They look horrible. Thought that would have been it. Another breakpoint here. Let's get in. I use the SR for the SC, so that's of course not going to work. Let me just look at the parser. This is what I should have been doing the whole time. They all look like they're there, so it might just be working now. A much bigger number. I'm under the minute limit, so boom, got it. Parsing, very fun. Turns out, blah blah blah. The previous 8x8s have been shared parts between multiple blocks. Okay, sure. I guess I read this now. Example. We finally, not finally, got another one for that one. Hopefully it's accurate. It's on the following notes. If you were to separate the given section, let me get my new ones. Okay, so more index math to parse the universe. We'll look as following. So the top left block. Well, wait, what top left block? This top left block? Why is my cursor changing? Oh, copy any block. That's nice of them. Oh, they're overlapping. I see it. Oh, so my world parser is gonna have to do some work there. Man, what are we doing with question marks? From the first dot from the top, the only symbol that does not have a pair is V. So the dot must be replaced with the symbol V, as must the associated question mark. There is no... Oh, there is a question mark here. Why are you putting question marks in my code? Must deduce during your work. There is one symbol that matches, identify all and their combined powers. Okay, what do I do with question marks? For the first dot from the top, the only symbol that does not have a pair is V. First dot from the top. That's an L. What are you talking about? The dot must be placed with the symbol V. Oh, that's top right. The only symbol that does not have a pair in the associated row is V. As must the associated question mark. Why are you saying it's V? Why V? Because there's a V in here. Okay, so am I looking for the character in the non-question mark thingy that doesn't repeat twice? Why couldn't I make it a G? I don't know why it's a V. Oh, jeez. Same reasoning. Okay, so they're repeating the reasoning. Solve all the blocks. Oh, do not solve the bottom blocks? That's weird for a thing for part 3 to say. So wait, only the top? What have I been given? I've been given a lot of tops and bottoms. So it means every other, so basically the odd numbered rows, we don't solve. Sure. Okay, let me look back at these question marks again. The second dot must be an X. Okay, so I'm looking at this, and it's saying this one has to be a V. Why? Okay, it says this one has to be an X. Why? I mean, I see there's an X up here, but V was also at the end. What's the next one? Third must be a Q, so Q must be in that one. There is no Q at the beginning of that line. Solving the next block is simple, right? Ooh, I hope that is left to right, or it's like solve the first one, makes the second one solvable. Or it could be a situation in which some of them aren't solvable until this one's solvable. The only symbol that does not yet have a pair in the associated row and column is B. Does not have a pair in the associated row and column. Oh, the same row has pairs. I never realized that. B, B, K, K, M, M, L, L, W, W, G, G. Okay. I never saw that for some reason. Okay, I think I got it. So now I just need to do the world parsing. And the tricky part, I guess it's not tricky. No, it will be tricky because I will be manipulating things that are shared by others. So I don't think I'll be doing the parsing. I think it will be just mapping it to where things get changes. So solve quest 3. Let's do this. Okay, quest 3. Yeah, I think I'm just going to go into solve quest and rip out all these bits, because we are not, unless I do deparsing to reassociate things, we ain't doing this. So for every world of worlds, let's just bring this into here, right? Drop the new cars. Drop, no, I said indent. Be indented. There we go. And then the word is new cars. Okay, we're getting there. Now the trick is we can't do that. Cannot do that here. Yeah, so the world is this. The rows and columns are unfortunately going to be changing. Let's go to the parser. Some of the logic here is all worthwhile. We don't have double lines. Let's take what we can. Do we have an example for this? Okay, we have an example. So it is 1, 2, 3, 4, 5, 6, 7. Okay, so row width -2 divide 6. Cost column, world column, input call count equals world 0.length -2 divide 6. Let's get Wallaby back on here. 2. Excuse me. Oh, are we running on my sample? Yeah, we're running on the sample. So we are only seeing a 2. Okay, so the next one, whatever I calculate, should be 2. Cost input row count equals world. The same logic. I don't think we share any vertically, so it's just 1, 2. No, we do share them vertically. So it's world.length -2 divide 6. Nope, that's not what I wanted. 13.6. Oh, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 14. 13. No, so it's 2. 3. This doesn't scale. I don't think my other one's going to scale either, actually. Let me bring my only to the other. So it doesn't work on this one that easy. It's not going to work on the other one that easy. Okay, 2 and 110. That one actually doesn't seem too bad. Let me... It's basically how many groups of 3s I can find on a single line. That's 20 selections. I only have 20. What did you find? 100? Excuse you. So if I just find 0, 1, 2, I'm just gonna sheet for that the column count. 2.split, not splice. Jeez, split. Okay, what? Oh, because you're an array. Whoops. Okay, you're a string. There we go. Dot split. Dot. I think it's the length -1. Boom. There we go. Now, how many of these do I do? I basically count how many 4s we have. So if I can go 0, 1, 2 and just get that column, because second call equals world.map r 0, 1, 2 dot join empty string and then split triple dot length minus 1, and this is what I was looking to calculate. 210, 220. That makes much more sense. Okay, we got those. Woo, boy. I'll put that back on. So what I need to do is get the beginning and the ending row and column for each section. So the easy one's going to be 0, 0. How do I calculate the next one? For let r equals 0 or less than, for let ir equals 0, ir less than input row count, ir plus plus, if ir modulo 2 equals 0, or not equals 0, continue, because we're ignoring the odd ones. Okay, and then it's let AR, let R equals IR 1, 2, 3, 4, 5, 6, 7, 8 times 8, I guess. 0, 16, 32, 48. I just need to log the thing at that position. Console, or I just need to see it. Log, not group, log, world. Hello? Hello? The world is being split. Cannot read undefined, reading 0. Fine. Star star NW star. So let's star star. What the heck am I looking at? Alright, so it's 0. Oh, I'm looking at the real one. Yeah, let's not. I think I have enough to look at it now. Yeah, let's not. Okay, so we're looking at 0, but we're not going to the end. Let's fix that. 0, 16, so that's undefined. Plus 8? That feels wrong. No, it's gotta be multiplication. Oh yeah, we're going to be skipping this one. Let's not skip it, just so I can see my math is good. Hello? You're missing something there, buddy. What? Okay, finally. 0 and 8, so the 0th is this one, the 8 is WQ. 1, 2, 3, 4, 5, 6. Minus 2. 8 minus 2 times IR. Whoops. 0, 6. I don't know if it works enough, which I'll be able to find out with the column. So for same thing. Then I'll nest them. Okay, I went a little too far for all those. Input call count. Yep, so we have 0 in C, 0, 6. Dang it. Fine, give me more. I need to put more in my input for this to actually test the parser. Where'd it go? Here it is. Sure, 4 of them. Chop that off, chop that off. There we go. So my row should allow me to know if my math is good. 12, 18. NS, XRT, ooh, I've seen some differences there. 0, 6, 12, 18. Let me make sure that is correct. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, that's correct. Because when I chopped the things out, right? Yeah, me chopping things out made it a little more inaccurate. Okay, but I'm confident in my math that it is a math. Okay, that's good. So that means my row things are good, my column things are good. I just need to actually do them. So we'll go row, and then we'll go column, and then we'll stop logging all this stuff out, and we won't do that on the ith tooth column. So now that we have this C, we know we need to go 1, 2. It's basically the same logic I had up here for my parser. So it's that plus input width and that plus input height will give me the positions and ranges. And I won't be putting them in the lines, but I'm going to be using them. IR. I guess it's IC. Call count, which is width. And row count, which is height. Right, instead of doing this, I need to be on that position and do the manipulations. So, yeah, also these calculations are different, so let's fix that real quick. Great, so we have that, We don't want to build lines. We just need to process them appropriately. Let's start. Yeah, we need to define these, unfortunately. Start R and R. And it's exclusive, these. We need these bounds for when we do the iterations to look around for stuff. And yeah, we have can calculate those up here after our continue. I'll get it in there, come on. There we go. Let's start C. Let's start end C. Okay, now we can do start R, end R, start C, end C. Okay, now that we have all the pieces here, we need to actually do our logic here. We find question marks, that's where craziness begins. So we need to build up, once you're out of position, we have to check if it's not a dot. So if world, I guess I am dealing with the world, right? Yep, it's the world. So if it's not a dot, ignore it. Otherwise, build all this up, do this. If we find it, if we don't find it, basically all that logic are right there. And I don't think we're collecting the new characters. We have 2 words with powers, so we are collecting the powers for the words. So that means for every row and column, we have the starts. I'll let new cars equals to this. We will be collecting them. Then when we're done here, basically the logic we did before, which was this, right? And then add it to our total, which we have somewhere up here. We will now. And then we will return the total, of course. Do I have the right indentation? I feel like I do. Thankfully, this is part 2, so I can trash it. Okay, so I'm feeling pretty good about it. Now we just need to actually do this traversal on the other one. So R2 equals start R. Nope, start R. And that is and R. Start C. End C. We do this, we do this. Now what tells us, hey, question mark party? It's if there's a question mark, or maybe, so the problem is like if we have to solve these question marks out of order, it's gonna be real tough because I'll have to keep track of like, oh, these are the ones in the queue that I can't solve. Then as I solve something that touches one of them, it's like, hey, you might be solvable now. That's gonna be complicated. Okay, so let me look at this. Only that does not have a pair in the associated row and column. Was that a new rule introduced? Okay, sure. I was sorry. I let my brain get lost on that one. So basically, if there's a question mark in my thing, I need to do other logic, which is another way of saying if it's not found. Because if we look at this one, we're not going to find. Hold on. Let me look at this one. Why did we put an L here? There's an L here, there's an L here. Why didn't we put an X there? Well, there's no X there. Okay, so we're going to come across rows in which we find a bajillion things. So I think the way we'll do that is be like, hey, if there's a question mark in either of you, you're going this special route. Includes or call cars includes. We have a special plan for you. Else you're doing normal. You're normal. Now, calculating found, that's going to be the fun part for this one. So basically, find car that does not appear in both and is not a question mark. Cost, basically it's counts. Counts for car of row cars. If call cars includes car, cast is paired. Now, hold on, the pairing logic is in a single thing though. Looking at this one, it's B. So it's basically the ones that are duplicated that aren't duplicated. I just said that English. Cost row cars unique equals row cars dot filter. C R I guess we'll do the array. So a array index of C not equals array last index of C. There we go. Which I need to bring the character in here. And I'm using index of, I could literally be using the letter I. Let's do that. Row cars unique. Cars unique. Same thing, but for the column characters. Great, we did that. We found the ones that are unique and I both of them. One of them is going to be a question mark. We're going to need to not look at the question mark. Pretend the question mark doesn't exist. There is no question mark. There we go. So it's the ones that don't appear in both. So then it could be in either of them. But found equals row cars unique. What did I type? If there's only one, this will bring it out. Like so. Dangerous game there. Okay, boom. Either way, we found you, buddy. And we're going to put you on the world and add you to your thing and do all your power. And none of this is working because of a really good reason. Let's stop Wallaby because I think this is going to be an in-depth one. So let's make sure our generation of row and column characters are doing their job. Part 2 example, let's get in there. No, we're not doing that. Let's see if we're starting at the right place. I mean, I know we're skipping ones, but we haven't even gotten there yet. Also, what did it mean by bottom? We'll never know. I mean, we will know somewhat. I just ran it on the big one. Oh, nope, we're not going to run that either. Okay. This is bad foreboding. It would help if I was running on the right problem. Okay, so this isn't happening. Stop. At least I'm making it that far. It just means my condition isn't going because my ending or startings are wrong in some way. So let's look at that. We have start C and end C, start R and end R. So R is that, R is less. Yeah, you're starting at 0, you're ending at 2. Crazy idea. Oh yeah, what are we looking at? And we could be on a dot. In which case we will forgive you. Yeah, we're looking at a star. It's a top left star, isn't it? R and C are 0. Yeah, I'm not going to expect much there. Okay, we can continue there. C is 1. Yeah, we're not going to see anything until we get out of 0, 1 land. So keep moving. No, that's... You're supposed to have a range of more than freaking 2 characters. Input call count. Ooh, that's right. Times 8. Much apologies. That's for how many there are, not the width. So 1, 2, 3, 4, 7, 8. Boom, let's fix that real quick. Is my row count the same? I think it is. I know there was a square. 3, 4, 5, 6, 7, 8. Okay, let's see if we get that a little further now. Show me the indexes. Just show me the start and beginning, that'll help me. 0 to 16. These were meant to be the number 8, so, whoops, again. We will get there, believe me or not. Okay, let's see. 0 to 8. Finally. Let me just see what you collected. Let me see what you collected. Okay, question mark GWL. That's a column. XLNP. Okay, I can use my eyes for that one. Those are backwards. What's in rows is what's in columns, and what's in columns is what's in rows. I think that's always been a problem, but it's okay. Question mark GWL. Question mark GWL. So that is happening, and we got a question mark. So do your thing. No, you didn't. Yeah, you didn't do it. So I mean, row characters, column characters. How are we supposed to figure that one out? Why is this one an L? Oh, I don't know which one the question mark's referring to, do I? No. Okay, so that one I know is an L because I find an L in both the row and column. And I know the one that we're saying is a V is not a V because I can't find a character in both. Okay, so it's the inverse. It's if you can't find it, well, you gotta try the fancy method. So, not like this, not like this. So it's basically, if not found, we're going fallback method. You gotta have a question mark in you, and we gotta fix you like that. Okay, let's see how that fares. I just put a bug. That's on me. That's concerning though. Hey. Let's go to the first one, because that's the one I wanted to look at. Yeah, you found your character, I believe, so I don't really care about you. You're cool, you're an L. Yeah, I don't want to look at you. GWLP, you're gonna be something. You're a W. Yeah, and the next one's gonna be a G. I'll be real happy for you. Real happy for you. Ooh, here's the one where it fails. It's interesting. because we're only looking at this one with its partial state. Okay, we still know to look for it. How are we gonna know it's a V? Because the rest of the bits aren't filled in. Ooh, okay, so the ones that aren't found, we're gonna have to do another look over. Okay, that's tough, that's tough. Questionables. Interesting. So if we can't find one, then hey, you're a questionable. Now, do these question marks ever intersect? They don't appear to. I really hope they don't, because that'll be a whole queue of things of, oh, great. So I need the row, the column. I'm going to keep all the row cars. Well, I'll need to recalculate the row cars, so no, I will not be doing that. But so I'll need the information to recalculate the row cars. So it's start R, start C. Yeah, I can use those to generate those. I guess we'll do an else because we need to do. Hold on. If found, then congratulations, you're happy. Otherwise, you're not happy. You're sad. Get that indentation, get that, dedent that. And yeah, we don't do this just yet. We have to do this at the end. For const R C start R start C of questionables. Woo! Then I need to regenerate both of these. Thankfully, we got the data to do it. Boop, we did it. Const found world RC equals found. Then I need to find the position of that freaking question mark. It's gonna be tough. Question mark is this. If world R2C equals question mark equals R2 and C. I'll do the same thing down here. Of course, with the cool coordinates. So R is R and C is C2. Because that also means question, well, world question mark R question mark C is what we just found. Come on. There we go. Whew. That was a lot of changes. Yeah, gonna be, so yeah, we'll look at that before, after, then all of our questionables, I guess. Let's see how that rolls. Yeah, we're on that one. We're gonna find 3 good ones, and then we're gonna I think the next one, yeah, we don't find anything, so we're like, we don't know. Then we're gonna find, oh, interesting, is literally, oh, the next one is a thing. Okay, so then we're gonna be good until, I almost want to see the next one, which is a row down. What am I looking for? I'm looking for P question mark PJ. On P question mark PKJ. Hold on, where'd that one come from? FWWSSJ. Where's the double W's? Okay, there it is. It is here. Which means I am here. Yeah, maybe we don't worry about it. Okay, I'm just gonna not do this. I'm just gonna look at, you know what, let's let it run. Right, so we found the questionable. Let's regenerate all these bits. This is the concerning bit. Yes, you're the one I can't figure out. You're the literally, you're the V. You're the V in the world. What? These characters are not unique. You see them twice. GLW. There's a G right there. There's an LW. Oh, I'm looking for the other one. Dang, I have it. So I had these inverted. Oh, I bet this will work. No, BKMV. Oh, that's why I'm supposed. That's why I was supposed to do the double call. To yeah. Let me get this code working. I should have been. We're looking for things that only one exists of. Then we'll throw a set on this to get rid of them, I guess. There we go. And then for the other one. There we go. And I guess we never got rid of the dots. Oh, I got rid of all my places. Let's put those back. Yeah, we got rid of the question marks in there. So at this point, we'll only find the V if this code was working. And then now it is working. So in theory, how do we know what the bottom is? They're not solvable. Sectional wall is stable anyway, so the two blocks holding... Okay, I need to see what that logic is about not completing them all. Not every 8x8. So it's not the bottom, it's just not every. So basically I need to be like, try the best you can, but if I don't get X many number of characters in my runic word, you're not cool. So what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you don't give me 16 characters, you're out. New cars.length less than 16. Continue. You didn't make it, buddy. Still means I try, I believe. So I believe just in this example was the bottom ones, not the thing. So let's see if I got this good. One way to find out. That's one way to find out. And I run through the entire thing. I didn't run through all of them. Okay, there's the problem. I might as well check to make sure the V's worked. Yep, we found it, we spread it, we got the V, and we put it in the place, and then we replaced our question mark. We are amazing. Love it. Which means it's one of the other examples that fail. Ooh, means we failed for this. We failed for top left? Did we not fill in the world? 8 and 8, 16. How many do we got? So we filled them all into my knowledge. 12. Oh, we didn't add the new characters to the thing. Oh, this order is not right. Okay, I need an index for the character. Which means this is no longer a string, it's an array. New characters. Okay, we'll do that. Dot push. Found. Insert index new characters dot length. I feel like that's gonna be off by 1 to a degree, but we will see. So we have new characters, that's right, new characters dot splice, insert index, delete 0, add found. Where do I get that? Here, insert index. There we go. Yeah, keep it as an array. So the trick is I need to track it there. That's the main place I need to track it. And yeah, this might be wrong, but I can adjust it down there. Okay, so we have all of our cool characters. There we go. They're all here. They're all amazing. Wait, we always need to push something in there, though. New cars.push, which means we did need to actually delete one. Ooh, let's fix that. I think it is -1 now. Don't run, debug. Let's get back in there. Okay, so third, fourth. There we go. New characters. So LWG LWG. So this is the first one we target. We found the V. We're amazing. What is our insert index? 3. 0, 1, 2, 3. So we get rid of the first question mark and not the second. It's going to be hard to tell. Boom. Okay, yeah, that was pretty easy to tell, actually. I lied. This will get rid of the next one. Insert index of 4. Boom. Gonna get rid of that next one. The next will be insert index of 10. Yeah, this is working like a charm. Let's go to the error. Okay, I said go to the error. Don't explode on the error. I do not have that set up, I guess. Breakpoints. Yeah, caught, uncaught. Okay, let's just give B breakpoint. Here we go. Okay, what is your problem? 13. You end on 14. I mean, let me look at the world. You have 12. Dang it, this... Okay, input, we have 2 rows, we have 2 columns. Alright, so you're supposed to start at 0, and then start at 6, and then start at... well, that on the other side. So my start R and I end R are not right. So start at 6, end at 14. Well, it's supposed to be where you start at, you just end at plus a little. So I bet this math, did I goof up the order? Six plus 8, 14. The rows are 8 wide. And I've seen all the characters be collected, so I'm pretty sure. Interesting. What am I seeing wrong? No, 13 world total. Math ain't mathin'. Okay. Start 6. So let me just look at the world, I guess, on these rows. World, start R. Yep. Start R, and then it's 6. So star NSH. Star NSH, that's correct. And then end R, and they say that's a 6, so 0, 1, 2, 3, 4, 5, 6. Our end R is 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It should be 13. So I just need to minus 1 all my ends. It feels like something that would grow worse, though. Like, then I need to minus 2 when it's 2 out. I just need to find the calculated way to calculate it. Of course, obviously. With the offset in mind. So I see... and this probably is affecting the columns too. 0 to 8. Well, we're not on the next column. So let's figure out a math for this. 2 times IR. So IR, yeah, times 8, which puts me on 8, while on 0 was doing nothing. 2 times IR, 2 times 8, 16. So this works. I don't think these maths work for what we need them to. I just need a 3x3 to test this on, basically. Three by 3. So I just need to duplicate, what is it? These characters. Nope, supposed to be sharing one. Those characters. think this is right. My eyes will tell me if I'm wrong. They seem right. I missed one. And then the final bit, we just need a whole new bottom. It should be doable like that. It's supposed to be a shared. It should be doable like that. There we go. Okay, so now we have a 3x3. And we're just gonna not run them at all. So yeah, we're just gonna do some tricks just to get this outputting. Yeah, sure, we'll just do that, and we'll just do some bug lines to get this to spit out. Okay, here we go, our 3x3 example. Let's get in there. Well, we need to start in the row, so let's not even go that far. Get off that one. Come on. Yeah, 12 to 20. So it's supposed to be start R plus 8. So is my start R correctly? That's what we need to check first. Come on. So double star XRTK. Yes, it is. So my ending should just be that plus 8. I don't know why my brain is not just snapping to this. Come on. Yeah, 0 to 8. 6 to 14. Why does 0 to 8 work? 0, 1, 2, 3, 4, 5, 6, 7. It doesn't? 1, 2, 3, 4, 5, 6, 7. Wow, when did these get so small? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I just can't count. So yeah, 0 to 8 because it's minus 1. So that's 6 to 14. Because it's 0, 1, 2, 3, 4, 5, 6 plus 8. 7, 8, 9, 10, 11, 12. I love math. Math is great. Counting is great. One, two, three, 4, 5, 6. There's no bottom here. Where'd the bottoms go? I'm straight up just missing a bottom. What the heck? What the heck? Why do I not have a bottom? Did I copy this wrong? Oh my god, I copied it wrong. I hate to report people. The idiot was I. I am the idiot. Watch it work. I mean, watch it work once I remove these returns. It was me all along. I mean, hey, we can simplify this one up at least. Start C plus 8. Wow, look how fancy that is. Okay, at least something else is wrong now. I am never finding my question mark. You shouldn't be running on things that ain't got a question mark. What if there are multiple question marks? No, I should still find a question mark. Someone else? No, someone else can't get rid of your question mark unless you get run over it twice. Let's... I mean, yeah, I wanted to bug on this and hit that breakpoint, I guess. Hit it! Okay, what are we dealing with here? Oh, am I running? Okay, I'm not running on the 3x3. I was about to be really worried. NW. Boy, you got a lot of question marks, don't you? What? So, row and column 0, 0. Aha, on the second row. This is what I was talking about, like, you might not be able to solve it there, buddy. Is this the unsolvable bit? I mean, we found a bunch of them. You're telling me you didn't find question marks on your row? You didn't. Why are you in the questionables? You're in the questionables because you couldn't actually find it. Ooh, that's the problem. Gotcha. Else, if there's a question mark, you got a question mark. Row cars includes, or call cars includes. There we go. Which will leave us in a state of, hey, we're under the 16. We're still going to process them because we're cool like that. Okay, you shouldn't be adding things to questionables if you ain't got a question mark. So how'd you get here? How did you get here? You're literally the same one I just looked at. So row 1, column 0. You should be solvable. You get solved, buddy. W, so HG double T. Oh, this is completed. I can't see that. You are missing a thing. Are you a dot that just made it through? One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Hey. And how did you make it through without a question mark? Only people with question marks can make it through. Okay, now I'm breaking on everyone with a question mark. Well, I'll use my eyes here until I find the one without the question mark. Same row? Same column, rather? Something with 2 question marks in it. That's tragic. So the trick is WQW question mark L W. Okay, what are we looking for? MVKN. Okay, I just need to actually look at it, I guess. Jeez. Okay, so column 5, row 8. So it's 0, 1, 2, 3, 4, 5, 6, 7. Column 0, row 1. Right. Okay, that's why you're down there. 0, 1, 2, 3, 4, 5, 6, 7, 8. WQ question mark L. I guess you already found a W. Happy for you. Yeah, so this is one of those unsolvable ones where these are unsolvable and you're supposed to figure that out. So I think what we do is we just try and go through it, and we just keep trying and trying and trying. So I think what happened is someone replaced your question mark. What the heck does that mean when someone replaces your question mark? Do I just throw this in a try catch? I'm like, we tried, it's a baddie. If not question mark, continue. Give up. The answer was give up. Hey, the answer was give up. Oh, I didn't like that one. Yeah, you wanna try again, buddy? You wanna? Oh, there's a skip on it. I wonder why I didn't like it. That's a number. I'ma put it in. Oh no. I wanna make sure other things. Oh, this is the most. What am I supposed to do with this? No. I mean, I know it's a weekend, so I mean, this is where you should have downtime, but no. Okay, so there's a chance this might not actually be the number. I'm gonna keep it over there just in case. If this is not my number, though, whatever shall I do? So I need to determine how to detect an Where'd my internet go? Great, everything wants to just go down on me. Quest 10, was it me or was it you? Nobody knows. I will know. We'll find out right now. No. Okay. So, yeah, that just didn't work. But it's working on the real one, which is concerning. And the 3x3, I don't even know the correct answer. Okay, I know that 3x3 is broken. If I were to fix the 3x3, though. Actually, I don't think the 3x3 would be valid because, like, the question marks and the places and stuff. So I don't get a 3x3. I just live with it. Yeah, I think I have to better detect the unsolvables, which in my mind is building up the questionables, trying to solve them normally, trying to solve them fancily. So it's basically just having a queue of, hey, these are the ones we need to keep trying, and try all of them, each iteration, and if you may stop making progress, like you don't solve a single one of them, well, you failed. I'm still slightly concerned about the one that's actually causing me the issues here, because that one. So let me just get to all the questionables. There we go, all the questionables. 4 of them. 2 5 3 2 4 4 5 3. I could have swore 2 of you shared something. Oh, I'm looking at the successful one. Let's move on. Okay, man, just skip through all of them. Let's get back on there. Okay, this is the one. We got no questionables. We love it. Here's the one of 5 questionables where you have duplicates. Here it is. On the 8th row, you got like 3 of them you can't figure out. Now, yes, I know I was wrong. They are not solvable. Who said that? How'd you figure that out? So I'm just saying, like, hey, if there are any unsolvables on the same row or the same column, get rid of them. So what could be happening is that unsolvables on the same row and column are making it through and then mucking everything up. So const questionable rows. Yeah, because let me look at this, because the way it worked in the first one was that the row and column of all of our dots never overlap. Now, what would happen if, say, the row overlapped but not the column? I wouldn't be able to know which goes where. So, yeah, they have to not override. Rows equals this. Cost questionable. Calls equals this. For cost Q of questionables. It'd be easier just to do it up here and be like, I found one, get rid of it. Const others equals questionables. Nope, get back in there. Dot filter Q2 2 dot row, or Q2R equals Q dot R. So it's similar is what I was going to go for, actually. So if the number of similars is greater than 1, unsolvable false, length unsolvable equals true, and break. I did the same similar R. Oh, did not mean to do that. And similar C. Because I'm just using a different row and a different column. Yep, I like that. So if unsolvable, break. Or if unsolvable, rather, continue. Because it's unsolvable, buddy. So I should be able to find the same 8s and 10s when I redebug through this. And 2 should still keep working, or this example should keep on working. Well, yeah, I found the successful one, of course. Found the empty one, yep. Boom, we have Mr. Problematic and Other Problematic. I love it. So we don't accidentally solve any ones that are unsolvable. The number is different. Could have swore I had this number on my clipboard, but I'm gonna keep a track of these because we're getting into that kind of territory. Do not solve ones by guessing, you fool. Nope. Okay, this might be a stumper at this point. Okay. Because I can't tell which I'm doing wrong on, because it's passing the dumb example. Okay. Let's get a real good look at all this. So you said this at the bottom one. I think the bottom was just in this example. They're unsolvable, not every bottom. Right. So I'm trying to think. So I already have my matrix. The world is correct. Is the world correct? I mean, I can just go through it on the real one. It's not... I don't think I'm going to have any basis in reality, though, if I go through the real one. Let's go through the example one once more. Yeah, we have an unsolvable. And then we have solvable ones down here. Let me look at a solvable one. Well, we have this condition down here, rather. Let's stop that. Redebug. Yeah, so we have one that is solvable, we do it. We have another one that we solved, we did it. We have a 13 that we can't get through to, we fail on. 13 with more question marks, we fail on. I guess I'll look at the real one. It's not gonna help me. So yeah, we solved it. We could not solve it. It's weird, I saw 13s. Because 2 of them are on column 8. Yeah, question mark on both columns. I wouldn't be able to figure out which goes where. I wouldn't. Okay, let's look through it again. Right, so if I see 2 question marks in a row or in a column, it's done for. I could do this up earlier than I'm looking at it, but it's fine. Yeah, I'm not seeing it. So I mean, yeah, there's some optimizations I can make and move some stuff up, but that's not introducing anything new. That's just doing the same thing earlier. Yeah, I think I will take a break on this one. And I will come back to it when I have some better ideas. Part 3 stumper. Maybe, yeah, just looking at it or moving those things around will help, but yeah, gonna take a break on this one. I am back at this again with this quest. Oh, not gonna get rid of that. Everybody Codes Quest 10 Part 3. So, had some thoughts. Didn't actually get to doing any of them, but my theory is that so I'm solving things and then I can't solve a thing, let's say, and then I solve a thing, and the thing I solve, like, since this fills in question marks, that can be like the edge, like shared basically, I need to basically keep trying to solve things until I can go through an iteration of attempting to solve all the things and never solve anything. Let me make this make sense. So we got just a bunch of squares. This is the most inefficient way of doing it. Drop that. There we go. We have 3. We have 3 more. And then we have the last 3. So let's say that this one, unsolvable because of all the question marks. But this one we solve, this one we solve, this one unsolvable. This one we solve, and then as soon as we solve these 2, this one becomes solvable. But since we iterate top left, like we iterate left to right, top to bottom, we already looked through this one, we're like, can't solve it, so we don't even attempt to resolve it. That's my theory. basically throwing this thing in a giant while loop, and as long as we don't see any solutions made, then we basically give up. The trick here is, it's not really much of a trick, it's something I've done before. Let me remember, is there a part 2 example here? Part 3 example. There is. Does this work? It does. Okay. So as long as I don't break it, again, we don't have a part 3 example or a real example of this input I'm talking about, but we'll just try it out. So starts with a while loop of, we're just gonna keep trying. Just keep on trying. I think we can actually just use the totals, but I do want to add some optimizations here, because we don't want to look at every single puzzle input and be like, let's try and solve it. No. We want to only try ones that we have failed to solve. Which means initially, we want to try everything. So well, it's either 2 ways I can do it. I can have a list of things that we want to try, or a list of things that we should not try. Should not try would be the ones that we've completed. To try would be the ones that we have not completed. I mean, they both, I guess, amortize to the same at the end of the day. So const solved equals new set. I could do the math trick, which I think, so it's just the math trick to store a single numeric value from 2 numbers to 1. So I think it's multiply, and then let's not risk that, because I don't actually have an example to run this on. So we're just going to make this a thing of strings. And then once we get IR and IC, we're going to say const key equals IR hyphen IC. Doesn't matter as long as it has both values. If solved has the I key, well then don't look at it again. It's been solved. But then we do all the work. Blah, 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 blah. And once we solve it, this is down here. Why does this loop end? Okay, if this is the right correct position, let me jump to this other symbol. I'm paranoid. Yep, that's the right one. So once we do solve it, we say, congratulations, you've been solved. And the way we're going to track if we have done anything in this while loop is previous in current total. Previous total equals total, and so we've got a const. And then if they are the same, which is down here, if total equals prev total, means we didn't solve any. We failed. And therefore we break out. Let's see if that works. Good, no infinite loop. 18, 17, 64. Unfortunate. The exact same number. So either this doesn't work, or it does, and there is something else wrong. So I guess I need to jump in here and see if this ever gets triggered. So that'd be the great place to put it. Put on the debug point. And let's get in there. So previous total. Yep, they don't equal the same. So congratulations, you solved some. And solve contains a set of size 0. That's a problem. What happened here? You solved a whole bunch of them. You got a lot of totals there. You didn't put any in your set. Right there, you're trying to add one. You're going to do it. Where do I define that set? Dang it. That doesn't solve my problem, unfortunately. Just change the number. Of course it doesn't. Okay, so yeah, we go through this. We solve a bunch. Yeah, we made a bunch of changes, and this time we have 18,000, so we don't solve any additional ones. Interesting. Is that really how big this is? Yeah, I guess it is. Okay, so next approach would be actually refactoring a bit of this logic, because it got, unfortunately, a little bit messy. I really thought that would have worked, or at least given me a different number. I mean, I know it wasn't working before. So it could be that I'm not solving ones, and I'm marking them as unsolvable. Interesting. Here I thought I had it figured out. Cleaning it up might be the only way about it, unfortunately. I'm trying to think, yeah, I mean, it's working for the example. Is it still working for the example? Did I break that? Still works for that darned example. I was about to think I wasn't doing the correct end thing, perhaps. So if I'm going through all the rows, all the columns, I was trying to think like maybe I'd just make it go more, but I'm not going to get anything because it's still going to hit all the unsolvables. But if I run through it, I'll go to some of the unsolvables myself, and I will determine if they are truly unsolvable. So this is when you say it's unsolvable right here. Let me... Well, first, it's going to go straight to the ones that you haven't solved. So let's just go straight into there. Next endpoint. There we go. So we get to these coordinates, and we're going through. So position, we're going to try and solve. So 0, 1 apparently is an unsolvable. And I believe you. Let's... Well, we didn't get there. Why didn't we not get there? Something is stopping us early. Can't be that continue. Can't be that break. Okay. Let's at least get to this loop. Okay, fine. Made it. Oh, because it wasn't considered unsolvable. If it wasn't considered unsolvable, your total would have went up. Okay, you weren't unsolvable, which means you solved. Wait, new characters only 4. did that happen? Oh, because I made partial changes. Gotcha. So yeah, my resolving does not do what I want it to do. Because I put things in, and then when I fail, I don't take them back out. So what I'm effectively doing is I'm counting that 16 check, I think, is getting in my way. It used to serve a purpose. It no longer does. Let's see if it still works. That's a different number. It's a good looking number. I don't know if that worked now. I probably just got bumped. Like, nope. I'm going on the wrong problem. Dang it. Okay, but that was a change I was happy to see. Let's get back in there. So, one easy way I can do this is if it is unsolvable, put everything the way you found it. Basically resetting its state. Which means I'll need the positions of all new chars, or I could just use the coordinates and be like, hey, all turning to dots now. But I'm going to want the new char coordinates. Const solved easily. Congratulations. Easily dot push RC, and we don't even need this continued. I don't know if that's still doing there. If it's unsolvable, then solve easily for each RC. Nope. A world RC equals a dot. Put you back where you belong. It's a different number. I really should be keeping track of these. Give me the last one. Much appreciated. The number went up. I don't know if that's good or bad. Okay, back into it again. So we have one. We're saying, hey, if we solve you easily, great. If we don't solve you easily, the questionals take over. If it's unsolvable, then it's unsolvable. Otherwise, it literally has to be solvable. Maybe this condition did do something. Put it back. 216, 219. What's the harm? I don't believe there is a harm. Maybe there is one. Never seen it. What I really need is to come up with an actual example for this scenario and really test it. That's what's... Hey, there it is! Okay. Explaining this is going to be really fun. Because there's obviously has to be a case where I don't have 16 new characters, yet I solved everything. Oh, is this thing happening? Where I don't... Or I determine something is solvable, because I don't flip the flag, yet it hits this not question mark. That's what happens. Okay, what state is this? Because if I can detect that up here, then I won't need this weird check for, do I have enough? I think I have enough breakpoints though. Let's get off of that one. Yeah, we're good. Oh yeah, that one. So that 16 protects us from is already solved, or no? Cool. I didn't see a breakpoint hit there. 1-6. Oof. Yeah, I wrote some great spaghetti here, didn't I? I will explain it the best I can, though. So, starting at the beginning, we need to replace these dots with certain characters. And then all of those characters, red, top left, bottom right, form a word, return the word. The way we fill in the characters is we look at all of the characters on the row and the column of the one we're trying to fill in, and we notice the single character that is in both the row and the column. So you can see here the row is BVPT and the column is PRFG. The only character that appears in both is the letter P, so the letter P is our answer to this dot. And we go on, and we do that for all of them. Note that it does not matter that the order in which you do these, top left, bottom right, top left, random, because the characters on the edges, like these two border characters, are all the information we need to actually determine it. So like, even though P and T are now considered part of this row, your answer is always going to be B, pre or post filling these in. Part 2 was literally part 1, but do some math to turn it from a string into a number. First, just convert it to the one indexed character code, then multiply it by its position in the string. Then you add all those numbers together. Really wasn't much there. This is the fun part where they made parsing a little harder. So I believe in part 1 and 2, they also, well, part 2 rather, they secretly introduced, you're going to be given an array or a string that contains multiple inputs. Right here that is, where you can see just one big string, and here is one input, and here is another input, and they're just separated by spaces and new line characters. So parsing that out became fun. Or as I can imagine some math people did it, transposing your coordinates back to the original ones, doing some cool stuff like that. That became fun. I didn't get that fancy. Part 3 flipped that on its head by saying that the inputs were actually sharing walls, and they were sharing rows and columns. So you can see that these two row columns, I guess, on the left, these two columns on the right, but these two columns in the middle are shared by both the left and the right inputs. And then they introduced question marks, which could be anything, but you needed to solve basically the entirety of it in order to determine what they could be. So note how the dots never share the same row and column. If they do that, it's logically impossible to know which character goes inside. Because the way to solve for a question mark is look for, so you solve all the other ones first. So unlike previously where you solve them in any order, it's like, no, you gotta solve all the normal ones first. Then you can come back and do the ones with a question mark in the row or in the column. In this case, the pattern is if the row or column contains that character uniquely. So, for example, we have two G's. It can't be a G. We have two L's. Can't be an L. We have two W's. Can't be a W. We have two B's somewhere. Can't be a B. We got two K's. Can't be a K. We got two M's. Can't be an M. We only have one V, or one Victor. And since we don't have the other corresponding Victor, well, this character must be a V, which means this question mark must be a V. That's the new rules for these unknowns. And you do that for all of them. And then you add up all the powers, and you get your result. With this So not only do they change the input parsing of where, hey, you have shared things between them now, and yet these question marks you gotta solve. Oh, also, some of them are literally unsolvable. Don't worry about it. And then the part that I thought of and we just saw work was the fact that, well, yeah, some of them are unsolvable right now, but that could be due to question marks. And as you fill in question marks from the neighboring ones, you could be making it more solvable. Again, I don't have an example here, but imagine like this was a row of question marks. Question mark, question mark, question mark, question mark. That's a horrible example. Imagine this were a column of question marks. And you know what? Another horrible example. Let's just imagine this one question mark. So H question mark, which is this X. Let's imagine that this here, this one here, was not solvable due to that question mark. Just due to the logical fallacy or the logical condition of there was also another question mark on that row. Pretend there was. Then that block would have been considered unsolvable. Until this one was solved, turning that question mark into a character, allowing it to be solved. That piece there was what I was missing primarily from my solution. Yeah, that's actually what I was missing from my solution there. And the rest was just filling with this broken code. So, let me throw enough breakpoints down and then add the solution. Probably put my answer in there. Let's get that out at least before I commit to this. We zoom in. Make sure I got the rest of them in there. Oh, I have a dot only. Drop that. Resend it. I guess I didn't fill in all these. Was it? Oh yeah, because it's the, what you call it. There we go. I didn't fill in these. Boop. Okay, we got all those filled in. Let's at least drop the console logs. Great. Okay, we are good, ready to commit. Initial 10 solution, and then I don't know how successful this is going to be, but it is a refactoring time. So, part 1 works pretty well. Part 2 is just part 1, but use different parser. Part 2.5 is same bit, but use a parser where they're separate. Right, I'm able to extract them out. Part 4 is similar, but don't do parsing. Use math to figure out coordinates and all that fun stuff. And it's the math kind where they share a thing. So I think part 3 is the final code I want to use. I'll have to make it customizable if there are spaces between them or if there are not. So what do I want to call these? Are these rooms? What are we solving here? For the shrine, many of the symbols are engraved. Each sample, what's a sample? Okay, there we go. Fill in shrines. Great. So now we have to add a boolean, which is going to control my number math logic of, are they sharing the same things or not, or are they separate? So how do I determine that? I could do a space between and allow it to be -1, which would be weird. Let's start with that. Space between is a number. Okay, so yeah, we'll let that go, and then I'll figure out how to make that work soon. Let's just make this work for part 3. What do I want to return? I think I want to return the words. Then I'll let the individual code turn those words into whatever the heck they want. Yeah, I'll just return the words. So not input. We want cast words equals an array. It's a string array. There we go. And I guess we'll do pre-word count equals words.length. There we go. Okay, just make sure that was still on. So if previous word count equals words.length, yet and find anymore. So just return your words. And this math will be done elsewhere. Words.push, new cars. Gotta join them back into a string. Right, which means for part 3, I should be able to call this and do some math on my words. Give me all the words. What is it? Solve or fill in shrines. Notes, and I have -1. Remember, don't do nothing yet, but it will. I'm just gonna do reduce. Total word. Yeah, I can add straight to the total. So let's start that total off of 0. And just put these for loop right in there. I think I need the I. Yeah, I need the I because that determines part of the power calculation. Do I need C? No, I don't. Do I need BP? I don't. And that is all that should need. Yeah, let's see if quest 3 still work. Like a charm, okay. 2.5. Yeah, so I should be able to resolve both 1 and 2 with this. But 1, it's gonna be easy. It don't care. So let's start with that one. Return fill and shrines notes. Space between 0, because it literally doesn't matter. It just wants the word. So yeah, 1 should be great. No, it's an array. Yeah, not that. Boop. You only get 1. It literally doesn't care. Unnecessary complex for 1, but it works. Okay, now for 2. So who determined the extra spacing? Is it this 2 times? Well, actually, there is no spacing in this one, so I don't know where that came from. Before I look into this, because this one has the spacing times 8 plus offset. So my start was, yeah, I did math, times 8 plus offset, times 8 minus 2 minus r. If they're all touching each other, it'd just be the times 8. So this is what the thing is making it more or less space between. Okay, so I just need to figure out the number I put into space between to make it still calculate to what I'm looking for here. Start r equals r times 8. So then I subtract 2 minus IR. I just need to get here to see what it looks like, honestly. I need to fiddle with the numbers in my hands. Does example 3 notes give me something I can work with? Gives me a 2 by 2. I can work on that. Bottom right, I guess. Let me in. Yeah, start R is 0. Tells me literally nothing. Start R is 6. We have some information. Give me my notes. But that is the worst view I've ever seen. Fine, I'll take it to the next tab. Nope. I don't want to be scrolling down 50 lines to look at this. Fine, I'll look at this. It will suffice. Ooh, it barely suffices. Okay, so you start at 6. 0, 1, 2, 3, 4, 5, 6. That is correct. How do we get you to say we start at 8 and then 9? So attempt start R is 8. So 2 times IR. Because we gotta do it by the IR, because that's building it. What? Then it's minus. Could it be minus 2 times IR? And I can turn it into a plus. Right, so 8 plus, well, 8 minus 2, 8 plus minus 2. Right, it gives you the same thing. So if I swap my 2 for space between, and it's a negative 2, that will work for this example. Let's say my space between is 0. So that's 8 minus 0. Well, so yeah, that's going to be easy. Nothing happens. We say it's 1. So it's 8 plus 1 times IR. Okay, I think this is it. I think that's it. Space between. Let's try it. What's the worst that could happen? So we plus it, and we say space between. Now the first test is that we just didn't break 3. We broke 3. Whoops. Interesting. Did I not fill in shrines correctly? So I did not fill in shrines correctly. It was me. Okay, good. Fix that. Now, can we get this to work for quest 2? So I just return, then I do the math. This is my theory, which I have math down here. Where's my math? There we go. Function words to some powers, array of string, and then you're just going to do this. Boop. There we go. Return some words, powers, words, return, and hey, if you want, just let's go all the way. Love it. Now I can reuse that in my part 2, which is this returns some words, powers, not worlds, I just want the words, which I can't shove it there. I'll have to do it up here when I call all of the things, but instead of 2 and instead of 0, it's 1 because there's a space between them. Here goes nothing. Okay, I think we got it. I mean, we have a single function. We ain't done refactoring yet. Why is it 25? Right, because the 2 didn't provide it. Well, I should just be able to use straight up solve quest 2 for this. Yeah, like there shouldn't be a solve quest 2 and a solve quest 25 is what I'm saying. So let's find number 25 and replace that with this. Yeah, we'll also say goodbye to our parser. Solve quest 2. Drop this one. It should still function. Nope. Well, that would make sense. Boom. Okay. Getting better. Let's trim up some more things. Parse stack thing. It was useful. It did parsing. It's in the commit history if anyone really wants to look at it. But we don't need it. Okay, we have our quest solvers, our part solvers rather. We have our result summer, and then we have all of this. Okay, so let's figure this out. Let's rename this to samples. Grid. Input column count. Sample. I don't like this because it makes it sound like it's the number of columns per sample, but it's better than input. There we go. Yeah. Sample. Indexes, position. Let's just call it solve samples. And instead of previous, let's say start word count. Okay, so we have this. I don't know if I know. This isn't samples. These are words, found words specifically. And it's the thing I'm actually returning. So yeah, let's get it down there. Grid. Yeah, we need all this, unfortunately. Yeah, we do use the grid. And these aren't index row, these are more sample row and column, so let's rename that. Woo, where'd my F2 go? SR SC. I like it. We'll name this unknowns rather. Okay, I like this. These 8s are kind of consistent or constants, but they're fine. Let's fix that. Const sample width 8 const sample height equals 8. Now we can just use this 8 here. Well, if I'm using for the row, then it needs to be here, and then for the height. Boom. I'll look that a little better. Okay, now I think, well, I don't think I know. I want to use the math trick for these solved samples. Don't have it memorized, but it's SR times however many possible rows there are. Sample row count plus SC. There's a math way to smush them into one. It's not I key, it's SR times sample height plus SC, which really should be put in a variable. Nope. Okay. Combine row and col into single int. Call indexes. No, what's the thing? Okay, so here we go. Row index by number of columns, and then column index. So maybe I was just multiplying by the wrong one. That's cool. I do math backwards all the time. Where did it go? Here we go. Oh, did I literally put the different one down here instead of up there? That would do it. Doy. So that's why this wasn't a variable before, but now I can't put it in a variable now. Let's put it in a variable. And let's say const sample key is r times, now what they're saying is the number of columns plus column index. Sure thing, Gemini. Sure, you are never wrong. It was pretty right on this time. Okay, so I like that. If you already have it, then yeah, you don't solve you again. How much does this really help though? Oh wow, it's like 300 milliseconds. If that. Okay, so we have this, we have this. Do I need this end row? I use it a few times. Same for the end C. I'll keep it. Do these change though? I don't think so. So let's make them all constant. Same for the new characters. And okay, now let's look at this. Yep, we ignore the dot. We love that. Collect all the characters in the row, all the characters in the column. Get rid of dots, get rid of asterisks. At that point, you just should ignore them, not include them at all. Got to keep the question marks. They're important data, though. And then we'll do the exact same process down here. So yeah, this can be easily functionalized. Oh, when we find that question mark, we do some stuff. I can make a tiny function for character and row and column and line and direction. It'd just be these two lines though, basically rowing or columning. I don't want to do that yet. Okay, once we find it, yeah, if there are any in both, we find it. If there isn't, do that. Keep the solved easily. I don't think we need, well, we do need solved easily because that contributes to our 16 count, which is our good passing count. Inefficient, but it's what works for our condition right now. The alternative would be looking through and seeing if we have any dots left over, which is more efficient. I don't want to do the more efficient version because that will mean more rewriting of my code. Okay, let's circle back around to this. Let's at least move this up to where they're doing their thing. Let's look at these unsolvables. For unknowns of unknown, if there are two of the same row or two of the same column, get out of here, you're unsolvable. We could probably easily do this already with just a map of known rows, known columns, const row counts, const col counts. Don't know what the heck happened with my formatting, but we'll fix that. There we go. Row counts, column counts for const of unknowns. And we're just going to check if it already exists. If it exists, then we failed. If unknown.r and row counts or unknown.c and col counts, unsolvable equals true, break. Break. Otherwise, row counts are, well, these are sets really, so let's just make them sets. Rows, new set. So it's really unknown rows, unknown calls. And then it's, instead of in whatever, let's see if we can do this trick. Call counts There we go. Dot has. Then you failed, but it's not counts. So there we go. Upper unknown S. Boom, we got it. We got the unsolvable up there. Congratulations. Otherwise, unknown rows. Add unknown R. Same for C. Boom. That's the same logic, but done in a better way. Love it. If it's unsolvable, then unsolve the thing. What's the pattern for solving this called? We gotta have a name for it. Words. Obvious. Obvious. There we go. Obvious, and we have unknowns. I don't think I need this start R, do I? Ooh, I do, to calculate to rebuild those arrays. Yeah, I do need that. Okay, unfortunately. Okay, so unsolvable, false. If unsolvable, then it's unsolvable. Question mark. Row cars, call cars. Let's do the exact same thing up there. Have them clean themselves up. Unique row characters, unique column characters. For both of these, we do that. Yeah, we can do both of these in a one and then just grab it. So let's do that. Found equals row cars. Good. Next one, call cars dot map cars, and let's go for the fancy while we're at it. Flat map. Don't get to use that one too often. So we have cars, and then we want to do this whole line. We love it, and that should work. Well, we have to index by 0, get a 0th out, and that should work. Beautiful. Drop these. Do we use found elsewhere? We do. Great. I'll probably look into this a little bit. And actually, that's pretty what I was looking for. Do we hit this not question mark? Let's find out. Wow. Turns out you do everything right. Everything works right. Crazy idea. I want to call this something better. I mean, it is the location of the question mark, so I don't know really what I'm looking for. It's pretty accurate. Okay, let's leave it as is. If it's less than 16, triple equals 16, because that's really what we're going for. Yeah, this one could be inverted, because this is less ambiguous here. Loving it. Give me some of that real estate back. Yeah, and I'm gonna write a little helper function for these. It's gonna be bad, but we're gonna do it. Function get call cars, and then what are we gonna call this? Start and end. Yeah. Well, a number. Are these numbers? With a number, or it's a string. It's a string. I was about to be like, we didn't do numbers in this problem. We don't have a double start. We have a start and an end. Okay, so cars. Let's make it an array. That is technically more memory efficient than constantly adding to this string. And we're just gonna yoink these bits. There we go. And, oh yeah, so we also need a row. There we go. And then, I guess we want to both ignore and keep positions of. So, I mean, the ignores are always the same. I guess it'll also just be like, hey, we also have a question mark here if you were looking for that. We could do some really forbidden stuff, but we're not going to do forbidden stuff. If car, let's just do the bad one. If car equals dot or car equals asterisk, continue. We can do some fancy includes, we can do some other stuff. Let's just go for this. So this is gonna work exactly what I expect it to, honestly. Do we want this as a string or as an array? Fine. I think array is actually perfectly fine. So let's do call cars equals grid row, which is R, start C, end C, and just pretend this don't exist. Oh, regex. It doesn't exist. No pretending needed. Like a charm. So then we could do the same thing for rel, which would be great. Let's not do that yet. Yeah, we can do the forbidden stuff here. Yeah, I've never... I mean, I've done this in other languages, but not here. How would we do this? String this and a b. That's not an ampersand, buddy. Oh yeah, we can be all forbidden. No, we can't be forbidden like that. If we do this, yeah, again, we're breaking all the rules. Okay, if we cast it, I solved it. Nobody say nothing. Nobody's gonna say nothing. Yeah, let's do the negative ones. Everyone loves a negative one. Okay, so if I find a question mark, now do I want the question mark preserved in the array, or I want to throw it out like a crazy? Yeah, we already have question mark detection. Don't worry about it. We do not actually want the question mark. We just want the detection of the question mark. Okay, if car equals question mark, then cars dot question mark equals row, rows row, and column is C2, which doesn't really need to be C2 no more. Number is not assignable to -1. It's oh, I'm not assigning, I'm doing things. Which means it doesn't always have a value, which I should account for. You could be undefined, my poor soul. There we go. Doesn't this look great? I think this looks great. Nobody says nothing. Equals get call cars grid row, which is R, start C and C. Yeah, and we have all this, and then we can say question mark is one of these two fools. Well, question mark. Okay, I think I have it here. is not, well, it's or call cars question mark. This is forbidden. Oh, no, you don't want to do this anymore. Oh, it's an array of strings. Well, it's an array of characters. You can, yeah, you can't do a place on that. Don't worry about it. I can fix that for you. There we go. Let's make sure this still works before I go full crazy. Oh no. Okay. Again, going a little crazy here. If call cars question mark equals call cars question mark. Could have used that operator incorrectly. Nope, don't like it. Start R, end R, R2C, grid R, question mark, control it. You never return the question mark, do you? You got one job here, fancy pants. Give question mark. Not that. You do have a question mark at some point. What is it? It's there. Oh, it's column. No. I went the wrong way. It's my fault for getting all fancy out here. Still too fancy because now I gotta type it all down here. There we go. Okay, the fanciness prevails, and I bet this does work as I expected it. Of course it does. Okay. Now let's do the other half of this forbiddenness. Function get cars in line grid string and then whichever one you provide will determine the direction, I believe. So it'll be start and end. You gotta provide me those. And then it'll be row or column. So I guess it'll be row call, which row number call number. You gotta give me an object. I know, it's crazy. And then all of these bits. There we go. Now the trick about it is that if we provide a row, we're going to do the row. Like which one is traversal and which one is just providing the line. We gotta provide some discriminator to it, unfortunately, I believe. Well, we do need to provide both values. We just need to provide which one is being traversed. So let's give it row and column, not the weird object. Traversing tells us which is which. So it's basically just going to be the if won't change, the access will change. So let O equals start to end car. This will be traversing equals row. So if you're traversing row, you're not doing this. Otherwise, you're doing this. Grid O call. Leveling this. Ooh, our question mark also changes. We'll put that here. So if you're doing that, it's not that. But if you are at R, row is O, column Ooh, row call. So I guess we are going back to the 3-letter prefixes. My bad. Which means that code down there is going to break, but it's fine. Yeah, I think if I use this properly, where I'm using this in the easy point, it'll prove that it's working. So we have grid, start R, well, start C, and C, R, C. Yeah. We are traversing a column. Okay, if that works, then we're good. I feel like I might have done some. Nope, it works. I feel no feelings. Call calls, row columns. I just say the other one, good sir. No. Oh, that was inside. Okay. Interesting. Did not expect that one to fail. Let's put some things back. So yeah, that one's what's moving. The column is what is remaining persistent. The one I passed. Yeah, grid, start, end, row, call. I passed the call. Huh. Okay, let me just... dang the regex. Interesting. That's what I expect it to do. Cannot read undefined. Reading 65. Which part is it failing on? Cannot read 65 of whatever. Okay, let's put a breakpoint on this. Or debugs. Wait, which one's failing? You're failing because you're doing the wrong numbers. Everyone else okay? Oh, everyone hates it. Everyone hates my cool code. Let's get rid of the rest of these. Let's get in there. So start 63, end 71. Oh, yeah, I passed the start row and start column for both. That would do it, I'd say. Yuppers. Okay, we have that, we have that. That's all we needed for that bit. Now we get to do it down here. Equals get cards and long grid. Start C and C. RC? Yep, RC. Traversing the columns. Should be the same. Dang it, what I know I did something wrong here. Oh, the things changed. They're saying call. Yeah, it's only for changing everything every 5 seconds. But I can do the row columns now, which is I'm just gonna go steal this line. And then I do the bit with the question mark, which I can make it a cost and just figure out which one I want. Question mark equals row cars question or call cars question. And if I don't get a question mark out of this, I'll be really sad. Now, thankfully, I don't need to join these anymore because I don't need to do the replacing bit anymore. I can just filter through, get the uniques, assume I have a question mark here. It's a really bold assumption. No. So I made like 3 changes there. So I assume that one's not the problem. So it was working before I switched to the rows. Or the fancy rows. which start R and R. Row moves, column doesn't. I don't see what's wrong with that. I'll change the one thing at a time at least. Yeah, we'll just go for the join on both of them. Make it a little less destructive. Okay, it likes that. It just really doesn't want to do my replace. But why not? Why not? That shouldn't be a change. Huh. Interesting. These shouldn't have question marks in them. Shouldn't have dots in them. They shouldn't have question marks. Shouldn't have asterisks. Obviously, it's finding a character that it shouldn't be finding. So let's see what scalawags we got going on. Okay, I'm never going to actually see it because we're only showing. Well, we are finding a question mark. So as soon as we find a non-question mark. Hey, look at this. We found a non-question mark. That was quick. Yep, row columns here. Then you found a question mark. You're cool. Wait a minute. The other ones I should not have been finding question marks. What's there a question mark here? Did I not put the continue statement on it? Hey, look at this. It's missing a continue statement. Found it. Which means it'll work now. No. When we find a question mark, we don't want to look at it while the other code wants to look at it because it needs to detect there's a question mark. Which means I do need question mark removing code in that filter down there. See, not equal question mark. And your index isn't all weird and wacky. Hope that. Okay, that does work. I was concerned that making that do both would mess up the indexing, but it doesn't. Works like a charm. So we've got the row characters, the column characters, of the question mark. Which now that it's guaranteed. Sure, let's put it up there. Doesn't really matter. Found character. Reduced character. Be real fancy about it. Follow the lore. And then, which is technically, what do we call this? Sample height plus sample width. Not really. So it's -2 for each. So 1, 2, 3, 4. So what is it? Divide 2. I'm thinking of the math because like there is a math way of doing this. So you smush them together and divide 2. Basically the middle half. Nope, that's not how that works. Let me do it real quick. 8 times 8, 64. 64 divide 2. Nope. 4 times 4, 16. Yeah, I guess I need to have them first. How do I get 64 down to 16? Divide by 4. Math. Sample height. Divide 2. Divide 2. Hopefully operations will help me there. An easy way to find out. There we go. Do I need the words to be... Yeah, let's keep them words. Everything else expects them as words. Solve sample, add sample key. Okay, I am pretty much liking this one. New cars. Yeah, we need that as an array. So we'll just call this word. Unknowns. Obvious. Or. Yeah. What do we call this one? And both. Car and both. There we go. If character and both. Boom. You found it. You found it. Obvious. We found it. You know, we don't need to push to the word. We can just map over the obvious and the unknowns and just pull them out. Ooh, the order of these, though, would have to be accurate. I can make a single array of results, and then some of them would include basically the character. Yeah, but I'm gonna go that far. We're going to the next level. Cost changes. Congratulations, an array of this. Changes dot push. RC. And then car and both. And then start R and start C and insert length will be when we don't know what's going on. Here we go. So I'm going to try and just comment these. Else it'll be, let's make a copy. Changes, push, and then, yeah, your character, it's an unknown. We do need those start and ending indexes, though. But we have them? No, we do not have them. You got a character, though. Yay! Okay, so we have this. We're just going to go through our for changes dot filter. No, come on, more parentheses. There we go. We just want to look at the question marks. And let's get some typing going on in here. Our number, C number, our string. You're an array of these. Start R, number, start C, number. Yeah, you can keep them around. Do we need the start R and start C? Those are higher up defined. We don't. Look at that data getting leaner by the minute. Loving it. Great, we have types happening too. So if any of those unknowns are unknown, yikes, let's not do that. Which means we won't have to clean anything up because we haven't made any changes. Now we go through all of our changes that are unknown. So again, we're doing this thing twice. So let's do it once. That's not how you spell unknown. It's angry. Let's fix that. Go of unknowns. Nice, and we can do unknowns. We didn't need all these three after all. And yeah, I think we're going to loop through all of them. And here's the thing, these unknowns are in order, so we don't need to like do multiple loops as we solve through them. We can just do it in the correct order. So for RC of changes, let's grab the character out. Cost word, let's make an array down here where it's more relevant. Drop all this. I am committing. Word push car. Well, you don't push random car, you push your deduced character. But if car not equals question mark. That is the weirdest looking question mark I've seen. Word dot push car. Whatever you found, I believe in you. Then push that. If you reach the right length, you push your new word. Okay, big bold changes. I broke it a little bit. It's okay. And we have that. Of the unknowns, they're still here. If any of them are bad, they're bad. We don't change anything there. So for all our changes, if you're not a question mark, then keep ya. If you are a question mark, you're going through the thing. If we have enough things, we keep it going. Okay, so obviously I broke something. Duh. What did I do? Let's look at this. Make a few looky-loos. It was also with the example too, so I really broke it. Changes, 16 changes. Yeah, very, very cool thing. Unknowns, 4 of them. I don't believe we are unsolvable either. Let's jump on down. We're not unsolvable if we're going to build our word. Okay, yeah, we're building our word. Yeah, most of them are going to be here. We're going to do some stuff. Yeah, since this is the order we're finding it in, I'm expecting this to be good. So it could be my word order is wrong. How much we got in our word? 16. LWGB. Oh, where are my eyes at? B as in Bravo? LWG Victor. The heck did you do? Oh. Yeah, you need to actually fill in all the unknowns. Or all the knowns first before the unknowns can be filled in because of that. Yeah, these functions look at the world, not the memory. Huh? So I need to change the world, and then if I fail, I need to change the world back. So my whole idea about, look, I get to not modify the world to death, just died. Unless I don't use this and look into my changes for the updated ones, but I don't want to do that. Okay, at the very minimum, we are making it better by not modifying and unmodifying. We're only modifying it when we know we can make the changes. So let's... Unknowns. We can make this work. So, map... index, which is going to be what? Well, it's just going to be index. This is the information we need. Because now we need to go through the changes that aren't the things, do your job. And then for all the ones of unknowns, you'll have your index right here, and you can do your necessary splicing. Well, it's always going to be word push. Word.push car. So I mean, you don't even need the rest of this. It can just be a straight map at this point. Yeah, just cut out all the middles. Boom, we have it. We're not going to do that there. Only through the unknowns. We're going to do word splice at index, delete one character, and add deduced. Not the best. I think that gets us back on track. No. My index is wrong. They should match to that in the found. Nope, we lost the index is lost because they got the index after the filtration. We need to do this map before, which is expensive. That's alright. And now we get rid of the ones that are wrong. No. We're getting close. Let's look at it once more. We know what we're looking for. If we get it working, we are a golden. What's our word looking like? Look at our word. It's got all 16 of them in there. Let's watch the things. I didn't make the changes to the world again. So I need the R, I need the C, because this is going to do some side effect stuff. What is it we call this grid? I forgot. Yep, using map to do side effect changes. Don't you love it? Ooh, and now 3 is failing. Okay, now this is concerning, because that means I mess it up so bad that the example works. The real thing don't. If it's unsolvable, then I don't attempt to solve it. I only do this when it's solvable. I went too far. Okay, I had a working state. Let's get back to it. I think it was when I was in the triplicate arrays. Yeah, the triplicate arrays. So we make the changes, we put them back. Yeah, before we turned this whole array here, everything was working. Come on, go on, go on. Put those back. Those math was perfectly fine. There we go. This is where we were functional at. Yes, we were. Okay, come on. So we combine both into changes. We instantly make changes to our world for, well, the ones that we know. Do I make those changes correct? I do. I make those proper changes. Even though I'm reassigning question marks to question marks, it's not impactful. Push it to the word, which is what I'm doing right here, and keep obvious simply to allow me to do a rollback, which I don't need to do. I could only do the rollback here, so this was after there. I get all that. I splice the insert index 1 deduced. Is it possible? No, if it was possible that my insert index was wrong, the rest wouldn't be working. It's not the end of the world if I don't get it to this point. I'm happy enough with it, honestly. Done enough refactoring for this anyway. Done more refactoring than I should have for this. Yep. Okay. So final walkthrough. Oh, yeah, we can get rid of that now. I forgot. Okay, so start with number 1. Fills in all the shrines. They have a distance of 0, so like they're right beside each other, and we just want the 0th one. So first we convert our string into an array of arrays, or a matrix basically. We get the number of columns by counting the number of triple dots, which is weird because they're by 4 dots. So lucked out because it was never going to see them be any size different, but they are 4. So it's basically just a trick to do count on substrings within a string. You split it, do length -1. Exact same thing, but I'm doing the columns. Keep track of all these solved sample indexes or keys. Collect my words, and then I track how many I started with. And if the number I end with is the same, well, it means there's nothing more to solve. I go through all my sample rows, calculate the start R and end R for my characters, all my sample columns, generate that sample key using the old math trick when you're doing 2 axes of a number. If I've seen it before, don't look again. This is purely optimization, doesn't hurt anything, doesn't help anything. Then we can calculate our starting column and ending column, and then our 3 arrays: the word, the unknowns, and the obvious ones that we solve. So we iterate through it. We ignore the non-dots because they are not the ones we care about. We get all the characters in the row and the column with this little doohickey helper here, which takes all the information and which one we're traversing. From the start to the end, it gets the character based on which one we're traversing. If we're going through rows, column stays the same. If we're going through columns, the row stays the same. We ignore dots and asterisks. If there's a question mark, we do the forbidden art of it's JavaScript and we can do what we want by just adding an attribute or property called question mark to our array of strings and setting its value based on what you're traversing. And we do the exact same thing, but we tell TypeScript, hey, we did some crazy stuff, don't worry about it. For these traversals, it means nothing because we're just getting the characters. Once we have the characters, we're looking for the one that is in both. So char in both. This is one thing I lost when I rename. And once we find the character in both, we break. And then if we have found one, well, then it was an obvious one to found. We modify the world, we push it to our word, and we say, hey, this was an obvious one, just in case we need to roll it back. If it's got a question mark in it, then I don't think we need this else if. We did at one point because other code was failing, but now there's only one possibility. There's a question mark in there. Which means we don't need question marks. Which means we can continue this. Which means we can drop this filtration down here. Nice. Back on track. We get all the normal characters in here, not question marks, not dots, not asterisks. If we found a character in both, great, we were able to do it the normal way. If we weren't, though, it means there's a question mark, we gotta do some deducing. So we're like, hey, remember these? We don't need the start row and column, and we just need the index. So it can make some optimizations here. There we go. So yeah, once we do that, we're gonna have maybe some unknowns. So first we say, we got this. We keep track of the unknown row and columns. If we ever have the same unknown row or unknown column twice, then it will be logically impossible for us to figure out which goes in which. It's just not enough information, which means it's unsolvable. So if it's unsolvable, give up. And if it was unsolvable, hey, all those changes you made, put them back. Undo all those changes. This is the thing I was not able to optimize at the very end. But assuming it is solvable, either because our unknowns are all good or we don't have any unknowns. Let's go through all those unknowns, getting all the characters again. This time we're extracting the question mark row and column from wherever it is. Just pull it up from either. Then we go through all of these and effectively do the same operation on both the row and the column characters. We're looking for an element of the index that appears once. The trick here is that we only want things that their first index equals their last index. So if I were to draw an example, A, B, C, A, B. So if we do the first index of A and the last index of A is, let me add some more space. There we go. So the first and last is, sorry, I'm getting there. Art is not good. The first is 0, the last is 0, 1, 2, 3. They're not the same, which means this is a duplicate thing going on here. We don't like it. Next, we do the same thing, 0, 0. And it's like, hey, what's your first index? 1. What's your last index? 4. There are at least 2 of you in here. We don't care about you. But then you look at the C. Your first index is 2. Your last index is 2. You are unique, so we're going to keep you. This expression is kept truthy, which is this expression right here. We keep you by the rules and the logic of the problem. There will only ever be one, and we only care about the first one. So we index 0 this entire party. We flat map it to do the automatic, well, flattening of the 2 arrays. This spits back out. We call it deduced. We update our world. We turn our question mark also into whatever we deduced. And then we insert in our word at the index of this question mark the deduced character, also getting rid of that question mark. Now, apparently there's still a universe in which we don't generate enough, which is suspicious. There is not a universe in which we do not generate enough at this point, because the code all works perfectly. So we add our word to our words array. We say, we solved this, we are amazing. And this is the final check of, hey, if we haven't solved a single word since last time, give up. We're not going to solve anymore. Yeah, that was the entire flow. It works for Solve Quest 2 and Solve Quest 3 with the space between allowing for situations in which there is a physical space between, which space between is 1, and for situations in which there is no space between, or rather a negative space between, aka overlap, by saying -2. And that is it. This is a simple, I guess not too simple. I'll walk through this. So we're taking an array of strings. For each of those strings, we're going through all the characters. The power for that character is the index of the character 1 based multiplied by the character code 1 based. So A is 1, Z is 26, which this helps us calculate. Multiply together is the total. Keep returning that total. We don't care about the individual totals, just the grand total, so you can just keep summing it up like this. And yeah, that is everything. I know it was a toughie. That last stage of the factor, I threw that in the trash, but it was a fun one. And I hope that has been fun or enjoyable or educational to watch. It's always a pleasure for me.